In this video, we are going to study the numerical which are based on the S-curve hydrograph analysis. So let's proceed for this. See, basically S-curve hydrograph, as we had discussed in previous slide, that the S-curve hydrograph is nothing but the hydrograph which is plotted discharge versus time, obviously, but it gives us a constant or continuous effective rainfall for the indefinite period or for the given constant rate of a rainfall. So it means that the hydrograph that can be produced by continuous effective rainfall at a constant rate at certain point, the rainfall will be in a equilibrium condition, or it should be for the indefinite period. So we can't say that for this particular time the rainfall intensity may valid or may occur. So the technique of constructing a S-hydrograph is a very useful in deriving a unit hydrograph having a shorter or longer period from a given unit hydrograph. And this S-curve hydrograph is based on process of shifting or offsetting. So this is known as a superimposing principle. This is also known as a superimposing principle. Means what? We have to shift and offset. Offset means what? While the shifting, we have to add the horizontal ordinates, and we have to write down this added ordinates in the next offsetted or in the next shifted zone. So while solving the numerical, we are going to discuss here. You can see the this S-curve hydrograph, when it is derived, it gives us the effective rainfall constant, which is shown by the R0, which can be found out by inverse of, or by multiplying, or by a ratio of 1 upon TO. T, capital T, means the given unit hydrograph duration. When we are going to find out this ratio, we will get the value of a effective rainfall. So let's see the numerical which is based on this S-curve hydrograph. As we had discussed that we have to derive a shorter or longer period of a unit hydrograph from a given unit hydrograph. Means if the given unit hydrograph is in a shorter period, means if it is in a 2 hour, 1 hour, 3 hour, and we have to find out the longer period unit hydrograph, means we have to find out the 5 hour, 6 hour, 7 hour, 9 hour unit hydrograph, then we can adopt this S-curve hydrograph. As well as second trick, the important trick is that when the given hydrograph unit duration and the derive the unit hydrograph ordinates that has to be find out, that unit duration, it is not integral multiple. Means if given unit hydrograph is 2 hour and we have to find out the 5 hour unit hydrograph, then simply it is not an integral multiple. In the table of a 2, the 5 is not occur or is not existing. So 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8. Likewise, the table will occurring and table will be producing. So here also, see, you can see the given is the 6 hour unit hydrograph, and we have to find out the 9 hour unit hydrograph for the same catchment. So here also the given is denoted by the capital TO, like in previous numerical we had denoted the given unit hydrograph ordinates as a capital TO. Here the given is a 6 hour and the derived one, and which we want to find out ordinates, that is denoted by the small TO. In this numerical, the derived, and we want to find out derived unit hydrograph is ordinate is 9 hour. So our TO is a 9R. So simply the 6 and 9, it comes in the third, third table or three table, third table means 3 ones are 3, 3 twos are 6, 3 threes are 9. But 9 will not occur and will not be come in the table of a 6, or a 6 will not be generated or produced in the table of a 9. Means what? The ratio, if we are going to divide this 6 by 9, so we will get simply a 2 by 3. Again, when we want to divide this 2 by 3, we will get certain value, which is not a constant value, means which is not a 1 2 3, which is not a it occurs in a 0 point something, 0 point likewise this value will occur. So in this type of or in this situation, we can adopt the S curve hydrograph. And sometimes in the numerical, though the integral though the ordinates are in the integral multiple, so even though they will tell you, they will tell you to find out these ordinates by using the S-curve hydrograph. So let's proceed. See here, the 6R unit hydrograph ordinates are given. So you might be confused by seeing that time interval. The given ordinate is in a 6R, but here in the table, the interval is in a 3R interval. So see, this happened after analyzing or after taking the records of a precipitation for a day, for a month, for a year. So eventually we are going to write down these readings and write down this record. So certain period has been decided. For this particular time, we have to write down and we have to record this ordinates. So here, for the 3-hour interval, even also the S-curve hydrographs are constructed by adding a number of unit hydrograph of a certain unit duration. So having the same unit duration, sometimes having a different unit duration. So here also we have a 6-hour unit hydrograph and we have the ordinates also. So if we plot these 6-hour ordinates on the graph paper, so the value is given here. So if we are going to plot this, and after adding this unit hydrograph, a certain average amount, certain average ordinates that might be find out, and that ordinates will be plotted discharge against a time, and the curve will be rising, and this curve is nothing but a S-curve hydrograph. So how this will be plotted or how this will be find out, so let's discuss. So in third column you can see the offset ordinates are written. So what is exactly offset ordinates? See, first the given is a 6-hour unit hydrograph ordinates. So first basically we have to offset these ordinates by 6R, or we have to lat these ordinates by 6R time interval. So simply what we have to do, so we have to take these ordinates and we have to write down these ordinates from the 6R unit interval. So you can see I am writing down this 0 in front of the 6-hour time duration. But this is the offsetting, this is the shifting purpose. First principle is fulfilled, that we are going to shift or we are lagging this ordinate. But what is exactly a offsetting means? What we have to add these ordinates horizontally. See, I'm writing the 0 in front of the 6R. Okay. Now 0 plus dash is 0. Now next is a 9. So 9 plus dash is 9. Next 20 plus 0, 20. Now 35 plus 9, it is equal to 44. You can see here. So we have to add these given ordinates horizontally, and we have to shift or we have to lag these ordinates by a given unit time interval. Means first given time interval is 6 hours, so we have to lag these ordinates by a 6-hour time interval, and while lagging we have to add these ordinates horizontally, and we have to write down it in the proceeding or preceding table, preceding rows. So here you can see the 35 plus 9 is 44, 49 plus 20 is 69, 43 plus 44 is 87, 35 plus 69 is 104, 28 plus 87 is 115, then 22 plus 105 is 126, 17 plus 115 is 132, 12 plus 126 is 138, 9 plus 132 is 141, 6 plus 138 is 144, again 3 plus 141 is 144. So just remember, S curve is produced by constant or continuous effective rainfall of a constant rate. What? Constant rate. So here we will get a constant value, that is 144. See, 3 plus 141 is 144. 0 plus 144 is again 144. Again 144 dash 144. So value remains constant. After certain time or after a 40 second or 42 time interval, at the time of a 42 hour, your value of ordinates remains constant. So here we are successfully installed or we are successfully include the offsetting and shifting principle for finding out the S-curve hydrograph. See, if you are successfully done this process, so next process, it is a very easy. So this third column is very much important. So by which value or by which time you have to lag this ordinates. So just you have to read this numerical carefully and you have to decide this. See, for example, if the given unit hydrograph ordinates are in a let's see, or let's take as a 3R. Okay, 3R unit hydrograph ordinates are here given. So here if 3R unit hydrographs are given, so we have to lag these ordinates in, or we have to write down these ordinates in front of the 3R unit time interval. So likewise, the given, just read out the given time or given unit hydrograph ordinates, and according to this just decide in which or by which unit time you have to lag or you have to shift these ordinates. Okay, and while offsetting or while shifting these ordinates, you have to offsetting this or you have to add these ordinates by horizontal. Now let's move to the column 4. After finding out the offsetted ordinates for 6R unit hydrograph, so here the first ordinates of a 6R S-hydrograph that will be generated, and just simply take these ordinates and write down this again from in front of the 0 time interval. So the fourth column will give you and will give definitely tell you the ordinates of a 6R S-curve hydrograph. But we want to find out the 9R unit hydrograph. So if we want to find out the 9R unit hydrograph, so again we have to lag these ordinates by which unit duration? Obviously by 9R unit duration. So again here you can see in column 5, again I am going to lag these ordinates. See, after third column I'm not doing any addition, I'm not doing any subtraction. Simply I put the value, I put the ordinates, and simply I lag these ordinates, or I am written down, I am writing these ordinates in front of the specific unit time duration. So again in column 5, if we want to find out the offsetted S-curve ordinates of 9R unit hydrograph. So we have to lag these ordinates by 9R. Means we have to write down this ordinate as it is in front of the 9R unit duration. So again, you can see from the 9R, I am writing down all these ordinates as it is. Okay, now for finding out this difference between the, and you can say the offsetted S-curve ordinates and the offsetted S-curve 9R ordinates and offsetted S-curve 6R ordinates. So if we want to find out this, so we have to subtract this column 4th and column 5th ordinates. So in column 6, you can see the delta y, it is nothing but a difference between the offsetted S-curve ordinates, the given ordinates and the derived ordinates. So column 4 minus column 5, you can see horizontally we are going to subtract it. 0 minus dash 0, 9 minus dash 9, 20 minus dash 20, 44 minus 0, 44, 69 minus 9, 60. 87 minus 20, it's 67. 104 minus 44, 60. So likewise, our ordinates, or after subtracting these ordinates, our ordinates will be like this, from 0 again up to the 0. So easily we can find out. See, we want to find out the unit hydrograph. First of all, I told you earlier also that if the unit hydrograph ordinate, how you can find, and you can easily and confidently tell us that this is a unit hydrograph ordinates. See, the ordinates which is starting from 0 and end up to a 0. So these ordinates, it is simply as a we can say that as a unit hydrograph ordinates. And if the certain value is there, if 20 value occurs at the 0 hour time interval and it ends again into a 20 R unit 20 R unit time interval. So sorry, 20 again it ends up to a ordinates of a 20. So it means that it is a flood hydrograph having a base value of a 20. So we have to subtract this base value from each and every ordinate. So this is a simple technique how to inspect the whether this is a unit hydrograph or whether this is a flood hydrograph. So in the sixth column, you can see the after subtracting these two column 4 and 5 column, we will get the final ordinates. And finally, for finding out the unit hydrograph of a 9R, finally the unit hydrograph of a 9R time interval, here we have to multiply the column 6 by again same ratio, that is capital T O divided small t O. Capital T means the given time interval or given unit are ordinates, means here the given time given unit hydrographs are 6R, and the derived that ordinates or unit hydrographs that we have to derive is a 9R. So capital TO is 6R and small to is a 9R. So column 6, the ordinates from the column 6 multiply by the ratio of a TO divided by a small TO. So the ratio will be multiplied and the final value and final ordinates that has been find out, which is termed as a 9R unit hydrograph ordinates. So this is a technique, this is a simple method. By using this, we can find out or we can added the number of unit hydrograph, and then we can find out the S-curve hydrograph easily. Here only the important method and important stage is at the third, or that has to be follow in a third column, that we have to shift this ordinate as well as we have to add these ordinates by horizontally. So remember this is an important type for finding out the unit hydrograph ordinates. So here I'm giving you some explanation how the S curve hydrograph will be generated and will be find out. So you can read this procedure also. I hope you understand this method. If you want to solve the number of example and a number of numerical which is based on the various types that I had already explained in a various videos. So if you want to solve the numericals based on this all the four types, so just mm, comment and tell me. So I will upload more and more videos, and we will definitely solve, and you can get the confidence to solve this type of a numerical. So this is an important chapter. This is an important section. So just practice it and make it successful. Thank you. Thanks for watching this video.